All right, today we are talking about something really, really cool. A new AI model with a fantastic name, the Dragon Hatchling. And the big question is, could this be the missing link we've been searching for in AI? Let's get into it. So let's start with a fundamental question. We have these super powerful AIs, right? And then we have our own brains. Both are incredible at processing information, but they don't really think the same way at all. Our brains are this intricate web, a network. But a lot of today's AIs, they're built on something totally different. And that core difference, well, it's causing some major headaches. And here's the contrast laid out, plain and simple. On one side, you've got your typical big AI model. It's often a black box. We can see what goes in and what comes out, but the why in the middle is a total mystery. It's like flipping on every single light in a skyscraper just to read a book in one room. Now, the human brain, totally different story. It's incredibly efficient. It only lights up the specific neurons it needs. It's targeted, it's sparse, and because of that, we can actually start to understand its logic. So what's the big deal with these black boxes? Well, it's all about trust. How can you really rely on something when you have no idea how it's going to behave down the line? This leads to these wild, unforeseen failures. You might have heard of the paperclip factory problem. It's this thought experiment where you tell an AI, make paperclips, and because it lacks common sense, it ends up turning the entire universe into paperclips. It's a crazy example, but it gets at a really serious point. Without understanding the reasoning, things can go sideways in ways we can't even imagine. Okay, so that's the problem. And this is where things get really interesting. A new paper introduces an architecture that's trying to bridge this exact gap. And it has, honestly, one of the best names I've heard in a while. They're calling it the Dragon Hatchling, or BDH. And look, the creators are not shy about what they think they've built. They're calling it a potential missing link between our current AIs and the way the brain works. That's a huge claim. So naturally, we have to ask, how on earth does it work? What's the secret sauce? All right, let's get into the mechanics. The model reasons like the brain, by combining logic with learning. The whole idea is to take one key principle from the world of pure logic and another one straight out of neuroscience and smash them together. First up, we've got something from Logic 101. It's a rule called modus ponens. It sounds fancy, but it's super simple. It's just, if A is true and A leads to B, then B must be true. For example, if it's raining, then the ground is wet. You see it's raining, you know the ground is wet. That's it. It's about taking these basic logical steps, one after the other. Okay, and the second ingredient comes from neuroscience. It's a famous concept called Hebbian learning. You've probably heard the saying, neurons that fire together wire together. The idea is that the more you use a certain connection in your brain, the stronger that connection gets. It's like forging a path through a forest. The more you walk it, the clearer it becomes. That's exactly what's happening inside this AI. So here's the magic. The Dragon Hatchling combines these two ideas. It uses that basic logic, modus ponens, to take a step. And then it uses Hebbian learning to strengthen the connection it just used. So it's not just following a pre-written map, it's drawing the map and making the paths deeper as it explores. It's learning and reinforcing its own thought process in real time. And this combination has a huge impact on how the AI actually works inside. Remember that skyscraper analogy? Most AIs flip on all the lights at once. That's dense activation. But because BDH is strengthening specific paths, it becomes incredibly efficient. It only lights up the exact chain of neurons it needs for a task. That's sparse activation. It's focused, it's targeted, and it looks a whole lot more like a brain. And we're not just talking a little more efficient. The numbers are pretty wild. The researchers found that for any given task, the Dragon Hatchling only activates about 5% of its neurons. Just 5%. That is a gigantic leap towards the kind of laser-focused efficiency we see in our own heads. Okay, this all sounds great in theory. Power meets interpretability. But does it actually hold up in practice? Let's check out the breakthrough results. And the answer is a big, fat yes, it actually works. The paper shows that on language tasks, the Dragon Hatchling can go toe-to-toe with a GPT-2 model of the same size. So right off the bat, we know it's not just some interesting toy. It has the raw power to compete. But here's the thing. Matching performance? That's not even the main event. That's not the real breakthrough. The truly game-changing part is what this new design allows us to do. And it all comes down to this one phrase from the paper, monosemantic synapses.
Okay, I know, it sounds like a mouthful, but stick with me because what this means is absolutely revolutionary for understanding AI. So, monosemantic just means one meaning, and synapse is just a connection between neurons. So, a monosemantic synapse is a connection that means one and only one thing. Because the network is so sparse, researchers could actually find one specific connection that would only fire when the AI was thinking about, say, the concept of currency. Another one might light up only for European countries. Think about that. We can actually peek inside and see the specific concepts the AI is working with. It's like we're reading its short-term memory for the first time.
So what's the big picture here? Where does this all lead? Well, it points to a potential future, what the authors call axiomatic AI. It's about building AI that we can actually understand. The idea behind axiomatic AI is pretty simple, really. An axiom is just a basic, foundational truth or rule. So, an axiomatic AI is one where we understand its fundamental rules so well, from the ground up, that we can predict how it will behave. It's the total opposite of the black box approach. We're not just crossing our fingers and hoping for the best, we're building something where we understand the blueprint. And this isn't just some academic daydream. The practical payoffs could be enormous. We're talking about new ways to scale up these models, quicker ways to check if they're working right, and of course, being able to explain exactly what they're doing. They even did an early experiment they call model surgery, literally taking two different trained models and stitching them together. You can't really do that with today's AIs because inside they're just a tangled mess. But here, it might actually work. And that leaves us with one last, really profound thought to chew on. For so long, the whole game has been studying the brain to try and build better AI. But with something like the Dragon Hatchling, maybe the tables are about to turn. If we can build an artificial mind that we can understand completely from its most basic rules all the way up, what will that artificial mind then teach us about the one we've been trying to figure out all along, our own?